Hey guys, this is Igal with Kakao Academy channel, and today we are breaking down an exercise dedicated to a robot who's got a limited number of options when it comes to moves. And the description of the exercise says a robot is located at the top left corner of a row by column grid. So in our case we've got 3 rows and 7 columns. The robot can only move either down or right at any point in time. So in this case, this would be here or here. If we are talking about moving further, let's switch to a pen. So if let's say a robot is now here, so robot will be able to move here or here. Okay. The robot is trying to reach the bottom right corner of the grid. So for example, one of the options would be to go all the way to the end and then go here. Another option would be go all the way down and then take the path all the way here. And we've got a bunch of other options. Since we have these moves, we can do something like that, and so on, so on. So the question is, how many possible unique paths are there? So this exercise can be approached by applying several patterns, but let's start from, I guess, the most simple one and use dynamic programming concept to solve this task. That said, it's important to mention right away a few things. So if let's excuse me. Let's remove some of our stuff here. Okay. Some of this. Okay. And choose pen instead. Okay. So let's say if we are here and we know that instead of having 3 rows, we have only 1 row, right? So this would be it. So in this case we have only one option, because we cannot go lower than first row. This is our goal, so it's only one option. Same here, if we would have only one column, we would still have only one option. Okay, so this is number one. Number two, let's say this is our goal right here, and so let's think about number of options if let's say we were to have a grid 2 by 2 like this. So we can come to here by going down from this cell, or by going to the right from this cell. So this gives us one option, and this gives us one option. So considering this cell an accumulation of options from this cell and this cell, this gives us two options. So by using this pattern, we can switch to the coding part of the exercise and apply that knowledge to solve the task. Alright guys, so let's read through the description of the task again. A robot is located at the top left corner of a row by column grid. The robot can only move either down or right at any point in time. The robot is trying to reach to the bottom right corner of the grid. How many possible unique paths are there? And we have two examples to use to double check ourselves. One, to see if our solution works or not. So if we have 3 rows and 7 columns, we would have 28 paths. If we have 3 rows and 2 columns, we would have, so basically we're talking grid 3 by 7 or grid 3 by 2. The output would be 3 paths. Explanation. So once the robot starts going from top left corner, there are a total of 3 ways to reach to the bottom right corner. Right, down, 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 right, down, right, down. Okay. So knowing this and taking into account what we discovered on the previous slide, let's say that if row equals 1 or column equals 1, we return 1. Right? So we know if we only have one row or one column, for me it makes no longer sense to parse through a bunch of data, because it's already clear that we have only one way to reach the goal. Now, in addition to that, if we have if row equals 2, then return column. Now think about it this way. So if we have only 2 rows, how many options do we have? We can go down instead of going directly right, exactly same number as we have number of columns. So basically, if row equals 2, return column. Same we can say for column. If column equals 2, return row. Believe it or not, this might speed up execution of our code dramatically in case following the values are provided. For the rest of the values, we do need to think about the grid and create an array in the following manner. So we're gonna have a table or a grid called, let's call it path, and they say that it's gonna be new int where we have row and column. Okay, so we're gonna have array of arrays. So we're gonna have first array, second array, third array, based on rows and columns provided. Okay, so how do we move on from here? So clearly we need to parse through those arrays. That said, we do remember, right, that the first index of whatever data collection would be 0 in programming, not 1. We need to take this into account. So we're gonna start from the very latest one, where we say for int r, which represents the row, equals row minus 1, r more equals to 0, r minus minus, for c, which represents the column minus 1, c more equals to 0, c minus minus. Okay, so this allows us to parse through our grid, starting from, so we start backwards. We start from our goal and proceeding towards the top left corner with index 0, 0. So first we say that if r equals row minus 1 or c equals column minus 1. Okay, so we say that if we currently at the bottom or at the edge of our grid, there is only one option for that particular cell, and in this case, let's say that this cell has only one option. Let's say, oops, my bad. Say that path R C equals 1. Now for the rest, all the cases, let's say that path I, oops, sorry, R C equals path R plus 1 C plus path R C plus 1. Okay, and basically we're saying, okay, so if a cell next to me it only has 1 and the same below me has 1, then I am two options. So we're gonna increment these options all the way down to the very last cell of our grid, which, as we said, it has index 0, 0. And all we have to do here is to return path 0, 0. Okay, let's try our solution. As we said, the expected output for row 3 and column 7 would be 28. Let's run it. 28. Awesome. Now just to double check, let's specify 3 and 2. We've expected output 3. 3. Awesome. Okay, so this is the dynamic programming approach. That said, this is not the only way to solve this task, so let's review the recursion approach as well. Alright, to make our recursion work, first of all, we need to define default return values. So we say if row equals 1 or column equals 1, we return 1. In all other cases, we use recursion to specify row column minus 1 plus row minus 1 column, and let's see if we actually have it right. So let's try this one out. I grid with size 3 by 2, 3 rows, 2 columns, and the expected output is 3. So let's try and give it grid 3 by 7, and our expected output is 28. Alright, so this is the recursion approach, a little bit more conservative in terms of number of lines of code, but you should be able to provide two implementation or solutions in case you are being interviewed, as this one might not be sufficient. Thank you for watching, stay safe, please like and subscribe, bye bye.